So today we'll talk about rational inequalities. Yesterday we talked about how to solve rational equalities. That was where there would be an equal sign here. But today we're going to discuss when it's a non-equal sign or a inequality, greater than or less than sign. Okay, and so for the equalities, we were able to cross multiply these and solve them pretty simply. But with inequalities, you actually can't cross multiply. There is a method where you can cross multiply, but it tends to be pretty complex. So what we're going to do instead, you remember, for rational inequalities, you can't cross multiply. Alright, so do not do that. It will cause a big problem for you. Now, so what we're going to do instead is we have to set this thing equal to 0. And so I say 2x minus 5 minus 10 is less than 0. So I take the 10 and I pass it over through subtraction or addition. And now what I'm going to need to do, this is probably the most difficult part, is I'm going to need to get a common denominator. And to get a common denominator, the denominator is x minus 5 and minus 10. And so I need to multiply an x minus 5 here and an x minus 5 here, less than 0. So remember, in order to subtract things, I must have a common denominator. Now these have a common denominator, and basically it's going to be simplified down. 2 minus 10x plus 50 over x minus 5 is less than 0. And so you can see this is becoming a little more simple as we go here. And if I now look that I have like terms of 2 and 50 here, and I will combine them, so it'll be a negative 10x plus 52 over x minus 5 is less than 0. And finally, what I'll do here is factor the numerator, and I'll get a negative 2, and then if I factor out a negative 2 here, I'm going to get a 5x minus 26 over x minus 5 is less than 0. And so now we're ready to begin. What you want to basically do is always get it so that it's set to 0, and then you want to factor everything on this side. Once everything is factored, you can write down your factors. Alright, so I'll write down my factors over here. Negative 2 is a factor. 5x minus 26 is a factor. And x minus 5 is a factor. And since I have 3 factors, I actually only have 2 factors that involve an x value. I'm going to make a chart with, I'm basically making the same chart that we made in previous chapters, okay? And it's going to be the inequality chart. over here is going to be infinity, over here is negative infinity. Then I look at when this is 0 and when that is 0. So this factor is 0 at a positive 5. Okay? This factor is 0 at a positive 26/5. And you have to decide which one of these numbers is larger. 26/5 is 5 1/5. 5 is just 5. And so you have to write these two zeros up here in numerical order, with the lowest one coming first and the highest one coming second. 26/5. And now, like we did before, we put dots along with next to the corresponding zeros. Alright? And now we write down when each one of these factors is going to be negative and when it will be positive. -2 will always be negative. This one will be negative here, and then it becomes positive there. This one will be negative here, and it becomes positive here and here. So I've filled out my chart. Okay? So again, back from the top, I take my original inequality and I sort of set it less than 0. Gonna have to get a common denominator and combine like terms and then factor it. The factors get written here. Then the zeros of these factors get written here. Then you write the dots corresponding with each factor and then fill in your positives and negatives. Alright, so it's a lot of steps, but in the end, if you've practiced this last chapter, this should be pretty easy. Now you count up the negatives. 3 negatives multiply together to be a negative. 2 negatives and a positive are a positive. 1 negative and 2 positives is a negative. Okay, and since we're interested in when this is less than 0, I'm interested in negative values here and here, because only negative values are less than 0. And so the solution, we're actually done. Solution is 2x minus 5 is less than 10 when, and you use this interval here and this interval here. This interval is when x is less than 5 or when this interval x is greater than 26/5. And that is the result. Now there's one other thing. You might find that they'll actually put an equal sign here sometimes too. If they put an equal sign there, or less than or equal to, then you would just carry it down, carry it down, carry it down. Keep carrying it down until basically the end here. And then when you go to present your answer, you would have an equal sign there, and you would actually have equal signs there and there as well. So if there's an equal sign involved with it as well, you end up with equal signs everywhere as well. Alright? So that's basically the idea for rational inequalities. let's do another one. And it's always the same exact way, all right? Let's go with x squared minus x minus 2 divided by x squared plus x minus 12 is greater than or equal to 0. And we'll do this the exact same way, except in the previous example it wasn't already set less than 0. So we had to do that. We had to get to basically this part right here, okay, by getting a common denominator, passing everything over, getting a common denominator, simplifying it down, and then factoring it. So you would imagine that from here down, we're basically starting with something like this time, okay? With this one here, we're starting up, and so now basically the idea here is we just have to factor the numerator and factor the denominator. If I factor the numerator, it's going to be x minus 2 and x plus 1. If I factor the denominator, it's going to be x minus 3 and x plus 4. It's less than or equal to 0. Alright, you'll have to practice factoring these again. Now, since I've got everything factored, I'm ready to go. Once everything is factored, both the numerator and the denominator, I'm ready to go to the factor chart. So I'm going to build my factor chart. I'm going to write x minus 2 as a factor, x plus 1 is a factor, x minus 3 is a factor, and x plus 4 is a factor. So notice I have 4 factors here, and there's an x in all of them, which means I need 6 lines here. 1, 2, 3, 4, 5, and 6. Alright? And this one's going to be infinity, this one's going to be negative infinity. Now I must write down when this is a 0. This is a 0 at positive 2. This is a 0 at negative 1. This is a 0 at positive 3. This is a 0 at negative 4. And again, I write these things right here. I write them up here. Notice I planned out 4 lines for these 4 factors. Okay? And so I write them in numerical order. The lowest, the next lowest, the next, and the next. So a negative 4 goes here. A negative 1 goes there. A positive 3 goes there. Oops, sorry. Positive 2 goes there. And a positive 3 goes there. Alright? And so this is my factor chart. These factors were written here. The zeros here, then the zeros were transferred up to here. Now this would get a dot right there. This one would get a dot right there. This one would get a dot right here. And this one would get a dot right there. And now, again, I would go negative, 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 positive, positive. Remember, when I get to a dot, I switch. Negative, negative, positive, positive, positive. negative, 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 positive, negative, positives all the way. And I've filled out my factor chart. And again, now I count up my negatives going down this way here. So 4 negatives is a positive, 3 negatives is a negative, 2 negatives is a positive, 1 negative is a negative, 4 positives is a positive. Now we look back up here. Since I'm interested in when it is greater than 0, since I'm interested in greater than 0, right here, I'm interested in the positives. I'm interested in when it's positive. Remember, because it has the equal sign as well, greater than or equal to, I'm going to also have equals in my result. So let's now transfer this information here, here, and here into the final answer. So x squared minus x minus 2 over x squared plus x minus 12 is greater than or equal to 0 when I just wrote down my original function, or my original equation. When x is less than or equal to negative 4. That's this. When x is less than or equal to negative 4. And then also it's when it's between negative 1 and positive 2, or when x is between negative 1 and positive 2, or when x is greater than or equal to positive 3. And that's the result there. I've just taken this interval, and that interval. Okay? And so that's basically the idea for rational inequalities. Remember, you have to have everything set less than or equal to 0. You factor both sides, factor everything, numerators and denominators. Then you write your factors here. You put dots on your zeros, fill out your chart, and then get the positive and negative intervals. Reference whether or not you're looking for greater than or less than. And then if you're looking for greater than, you take the positive ones, less than, you take the negative ones, and then you write down these intervals as your result.